We now determine the open intervals in which the graph of y is concave up or concave down. So for this, we place the fact that the function f of x is concave up whenever its second derivative is positive, and whenever the second derivative is less than 0, it is concave down. So to determine the intervals of concave up and concave down, we should basically find the second derivative of the equation y. So let's find the second derivative. First, I'm going to write down is in a simple form. I can write down this as negative 3x power 5. This is divided by 270 plus 40x cube divided by 270 plus 135x and divided by 270. And so we can simplify and put this fractions. This goes 90 times. So I can write this as negative x power 5 over 70 plus we can cancel this end zeros. And so this reduces to 4 by 27 x power 3, and this actually goes 2 times. So basically this is x by 2. So we have put the equation y in simple form by reducing the fractions, and so we can easily find its derivative. So let's find the derivative of y with respect to x. I write down this as y prime, and this equals, here we have negative 1 by 90 is the constant, and we find the derivative of x power 5 using the power rule, which is 5x power 4. Then I put this 4 by 27 multiplied with the derivative of x cube is 3x squared. When we use the power rule, we put the power in front and reduce the power by 1. So it is 3x squared. Plus we put this 1 by 2 constant and find the derivative of x, which is 1. Can simplify this further. So y prime, which is the derivative of y, and this equals, can cancel this 90 with the 5 as it goes 18 times. So the first fraction or the first term is basically negative 1 by 18 x power 4. Then we can cancel this 27 with 3 as this goes 9 times. So the second term is 4 by 9 x squared plus the third term is half. So this is the first derivative of y. Now let's find the second derivative. So we have to differentiate this y prime with respect to x, which is y double prime, and this equals, I put this negative 1 by 18 times derivative of x power 4 is 4x cube plus I put the constant 4 by 9, and derivative of x squared is 2x. And then the derivative of half, which is a constant, is 0. So let's simplify this. And so this equals, this is 2, 2, and this is 9, 2. So the first term is negative 2 nines x cube, and the second term is 4 times 2 is 18 nines x. I'm sorry, it is 4 times 2 is 8. So this is 8, 9x. Now we can combine these two terms since we have the common denominator 9. So we can rewrite y double prime, and this equals negative 2x cube plus 8x over 9. And if we look at the numerator, we can factor out the GCF. The GCF of these two terms is 2x. So we factor 2x. And when we factor 2x, we should divide the term negative 2x cube divided by 2x. So this 2 and this 2 gets cancelled. And x cube divided by x is x squared. So it's basically negative x squared. So the first term is negative x squared. And similarly, we have to divide 8x by the GCF, which is 2x. And so this equals 4. So we have the term negative x squared plus 4 after factoring out the GCF, which is 2x, and this is divided by 9. Now we have to find the points where the function may change its concavity. So for that, we need to set up y double prime equals 0 and solve for x. Uh, this could be the points that we obtain may or may not be an inflection point. However, we determine those points where it may or may not change the concavity. So let's consider this and put this y double prime equals 0. So therefore, we get 0 equals 2x times negative x squared plus 4, and this is divided by 9. Now we multiply both sides by 9, and so we get 2x times negative x squared plus 4 equals 0. So either 2x equals 0 or negative x squared plus 4 equals 0, and this gives x equal to 0, and here we can add x squared to both sides. So when we do that, x squared equals 4, we take the square root on both sides, and so we get the value of x equals plus or minus 2. Therefore, values of x when second derivative equals 0 is x equals 0, minus 2, and plus 2. Okay, now that we have determined the points when the second derivative equals 0, our next step is to prepare the sign chart for the second derivative. So let's do that. So I put this number line and also put the points, that is negative 2, 0, and 2. And so here we have four open intervals, and we can do the test in which interval it is concave up and concave down by selecting some random points and substituting into the y double prime and understanding its sign. So this sign chart is for y double prime. Now let's consider this interval, that is from negative infinity to negative 2, and in this we consider one sample point. So I'm going to consider x equal to negative 10, and plug it into the second derivative. So therefore this equals 2 times of negative 10 times negative 10 square plus 4, and this is over 9. We need to understand only the sign, we don't need the exact calculation. So this is 2 times negative 10 is negative 20, and this is negative of 10 square is negative 100 plus 4, which is negative 96. This is over 9, and we have a product of two negative numbers, and therefore it's going to be a positive number. So it is positive in this interval, so we mark positive in this interval. Now let's consider any sample point in the interval negative 2 to 0. I'm going to consider negative 1 and plug it into the second derivative. So therefore we will get y double prime of negative 1, and this equals 2 times of negative 1 times negative of 1 square plus 4, and this is over 9. So here we have negative 2 times this is negative of 1 square is negative 1 plus 4. This is over 9. So this is positive and multiplied with a negative number is negative. So this is basically negative here. So I can mark negative in this interval. Now let's consider the third interval, that is from 0 to 2, and we once again consider some random point. I'm going to consider x equal to 1 and plug it into the y double prime. So let me copy the y double prime, and this equals 2x times negative x squared plus 4. This is over 9. So when you plug in x equal to 1, here it will becomes 2 times of 1 times negative of 1 squared plus 4, and this is over 9. So this is 2 times of this is negative 1 plus 4 is positive 3, divided by 9. So this is basically a positive number. So let me mark positive in this interval, that is from 0 to 2. Now let's consider the last interval, that is 2 to infinity, and we consider any sample point. I'm going to consider x equal to 10 and plug it into the second derivative. So therefore y double prime of 10, and this equals 2 times of 10 multiplied by negative of 10 squared plus 4, and this is over 9. So this is going to be positive, that is 20, and this is negative 100 plus 4 is negative 96 over 9. So this is basically a negative number. So I mark negative in this interval. So we have created this sign chart, and using this sign chart, we can now say that in which interval the function is concave up and which interval the function is concave down. So it is concave up wherever the second derivative is positive. So in this interval, it is concave up, that is from negative infinity to negative 2, as plus in this interval, that is from 0 to 2, it is concave up, and in the other two intervals, that is from negative 2 to 0, this is concave down, as well as in the other interval from 2 to infinity, it is concave down. So we write the concave up intervals as negative infinity, negative 2, this is union. The other interval is 0 to 2. Then we write the concave down interval, that is from negative 2 to 0, union 2 to infinity. Thus, we have determined the open intervals where the function is concave up and concave down.